sometimes when you go to graph a line by picking points, you're going to end up getting fractions. And some lines work out better than others. Some points work out better than others. But I'm going to show you that when you plug in this case, 0, 1, and 2, two of these are going to work out and give you a nice integer, and one of them is going to give you a fraction. And I'm also going to show you a trick on how to not get fractions. Okay, your best chances of not getting a fraction. So let's go ahead and work this problem, and I'll show you as we go along. In this case, I'm picking values for x. So I have 3 different numbers to plug in. I'm going to plug them in for x. So 5, whoops, let's go with black. 5x minus 2y equals 10. And in the first case, I'm going to plug in for x. I'm going to plug in 0. It's usually the best number to plug in. 5 times 0 is 0. 0 minus 2y equals 10. Negative 2y equals 10. Divide both sides by the negative 2 to get our y by itself. And we're going to have y equals negative 5. Okay, so we got a nice solid integer there, 0 and negative 5. Okay, now let's go ahead and plug in a 1 for x. So 5x, rewrite the equation from above, but instead of x, now we're going to plug in a 1 right here. It's in the x column. Plug in a 1 for x. We get 5 times 1 is 5. I can do better. Minus 2y equals 10. And now we're going to solve for this grumpy y. We're going to subtract 5 on both sides. Drop down the negative 2y equals 5. Divide both sides by negative 2. And we're going to find out that y equals negative 5 over 2. Okay, now that's not easy to put on a graph, but it's information, and it's information we can probably use. Okay, negative 5 over 2, if I made that a mixed number, it's negative 2.5. Okay, and I'm pretty sure you could find negative 2.5 on a graph. All right, let's go ahead and let's plug in the last number, which is 2 for x. So we're going to plug in a 2. 2 is in the x column. All right, I just chose 2. I could have chose anything else. 2 goes right here. 5 times 2 is 10. Drop down the minus 2y, the equals, and the 10. To get this y by itself, I need to get rid of that 10. I am going to subtract 10 from both sides. 10 minus 10 is 0. It's gone. So I drop down the equals. Right? I drop down the minus 2y. And what's 10 minus 10? 0. Okay, it doesn't disappear. 0 is a number. One more step. I'm still trying to get my y by itself. It's negative 2 times y. I'm going to divide both sides by negative 2. And y equals 0 over negative 2. 0 over anything is 0. Okay, so here are my 3 points that I'm going to graph. 1, 2, 3. Let me go ahead and pull a graph over here. Yeah, that'll do. All right, so you see the 2 easy points to plug in is going to be 0 and negative 5. And then 2 and 0. Okay, those just happen to be intercepts. Go to graph my line. Let's see how good I can do here. Nope, I can do better than that. Let's try this. Let's see if I can move that over. Nope, let me try again. Yeah, come on. There we go. All right, here's my line. Now, this third point, yeah, it's a fraction, but I can use this to see if my graph is correct. This is my test point. 1 and negative 5 over 2. Well, that's going to be 1 to the right and down 1, 2.5. Look at that. Right there. Okay, this is my test point. It is on the graph, and I can be confident that this line is correct. Okay, because my test point works out. Now, here's the trick. Okay, let me write down the word trick. Here is, it's not really a trick, but here is the trick to getting values in your t-table that are not fractions. If you're plugging in values for x, you want to make it multiples of 2. Okay, the coefficient of the y. So you want to make multiples of 2. And if you look, see the 2 worked out. 4 would probably work out. 6, 8, right? 4, 6, 8. If you were plugging in values for y, you're going to want to use multiples of 5, because that's the coefficient in front of the x. So the numbers that are going to work here are going to be 0, 5, 10, 15, -5, right? Okay, it doesn't always work like that, but your odds of getting nice solid integers and non-fractions are going to be by using multiples of the coefficients.